All right, for this problem, we're told that a man exerts a force F on the handle of a stationary wheelbarrow at A. And the weight of the wheelbarrow, along with its load of dirt, is 185 pounds. And that has a center of gravity right here at G. Now, for the configuration shown, what force must the man apply at A to make the net moment about the tire contact point at B equal to 0? All right, this is a relatively straightforward question and is similar to an equilibrium question. The only difference really is that we're not going to be drawing a free body diagram for it. All right, so we know that we want the moment around B equal to 0. So the sum of the moments around B is equal to 0. And we can take counterclockwise positive. All right, so for the weight passes by point B through this perpendicular distance here. It's a vertical force, so a perpendicular distance is horizontal, and that's 8 inches. So the weight, as it passes by point B, would try to produce a counterclockwise rotation. So this is 8 times W, moment arm times W. And we can leave that in inches. We don't have to convert the inches into feet, as long as we take all of the moment arms for the forces in this problem to be in inches. Now let's think about the force F. I'm going to break that into components. Let's get some force arrows. And I have a 60-degree angle off of the handle, but that's actually not the best way to work this problem. It's actually best if you utilize a vertical component and a horizontal component. So there's my two components. We can put a squiggle. This is F. You can think about this as Fy if you want, and Fx. We haven't added a coordinate frame, but once we add a coordinate frame, then those subscripts would become relevant. All right, so let's take each force individually. Point B is on the ground, so it should be apparent that for the Fx, the moment arm that I need is the height that Fx is above the ground. X is a horizontal component, and the height that it is above point B, perpendicular, that vertical distance is 26 inches. So the moment arm is going to be 26, so let's just put 26 times Fx. And if it helps you to see it, you can always sketch the line of action for the force. Let's just use green here. So X is horizontal. So here's the line of action for that force. And then, since X is horizontal, come from the point that you want the moment perpendicular to that. Okay, so that basically finds the shortest distance that X ever is from point B. And it's easy to see that that distance is 26 inches. Now, as that force, okay, as Fx, as it were, kind of goes past, if we think about transmissibility, as that force goes past this moment arm at B, that's going to try to produce a counterclockwise rotation. So this is a plus moment. All right. Let's look at Fy. Fy at its closest point to B, all right, if we think about, y is vertical, and then we come out of point B with a horizontal line to that line of action, then right here on the ground is the closest point that Fy ever is to point B. That's a distance of 37 plus 8. So let's put in our moment arm here, 37 plus 8 times Fy. And then we decide, as Fy goes past point B on its line of action, okay, so as it travels this way, when it gets to this point, it's going to produce a clockwise effect around point B. So this is going to be a minus term. All right, so you can always think about the way that arrow travels, and then when it gets to that closest point, this is going, as it were, clockwise around a face. Okay, that's it for this. Let's substitute our numbers. So we have 8 times W was 185 pounds plus 26. Note that we have the 60-degree angle here, and then this angle is 20 degrees because it matches the inclination of the handle that's given a short distance below. Fx is going to be, and remember, we're only dealing with magnitudes because we've already given these moments positive or negative signs based on this notion of the right-hand rule, or when the force passes by the closest point that it ever gets to be, what direction it is. So this is 26 times Fx. In this case, F is unknown, so this is F times the cosine of 80 degrees. We know the angle, we don't know the magnitude. Remember, that's what we were asked for. And then minus 37 plus 8, and Fy would be F times the sine of 80 degrees. And that has to be 0. Now, the only thing in the problem that we don't know is F. So this is a number, and then a number times F, and a number times F. So you can obviously combine these two into one number with F, and then solve it. And you would find that F is 37.2 pounds. And that's all we have to do for this problem.